The next thing I'm going to talk about is different kinds of meters and different ways to measure the values that we are calculating. So when we go into the lab situation, or when you're using these in real life, real world examples, things like that, you can actually get the measurements that you're after. So one of the things that we use is an analog meter. Now, all of the analog meters we have at their core are going to be devices that are calibrated to measure a specific amount of current. So to a standard, we're chasing the current down, the number of electrons passing per point per second, that is amperes, that's current. So what happens is we have these devices. And right here we start with this very first picture. We've got two meters that are right above each other. One, the first meter, has a scale that goes from 0 to 1, and then inside it tells us it is a milliamp, and underneath of it, that also symbol also means there that it is DC. So this is measuring DC current in milliamps, and this meter has a scale all the way up to 1 milliamp. Down here on the bottom, we're not told what type of current it is, but we can tell that it goes from 0 to 20 amps. There's no milliamps, there's no other markings on there to indicate what it is, so it's measuring up to 20 amps. Now, generally what we're going to see is most of these meters are going to be measuring smaller amounts of current, at least for the ones that we're going to use in this program. Once in a while, you'll see these bigger currents out. If you have a welder, sometimes these will have them on there. They're pulling a lot more current. They're definitely into the 20 amp range, 30 amp range for welders. Depending on the situation, depending on where you're at. So the way that these work is inside, as you can see on these between these two pictures. So this is the backside of what the meter looks like if we were to flip this thing around and take it out of all the housings that it has. So it has a little electromagnet here on the back, and then mounted around here is a ferrite magnet, or a natural magnet. And so what happens is, what we're doing with this is this magnet is going to react and create a magnetic field, which then this electromagnet inside is going to pick up on, and it's going to go back to some place. So because of the magnetic field here between these magnet poles, this is going to turn, the shaft is suspended in the middle of this. There's some bearings in there, and so it will go to a natural position. Some of these have adjustments, some of them don't. So like if you look on this picture right here, this is your adjustment. So you can actually adjust this thing a little bit, which will adjust the different components on here. It'll change the position. There's like a key in there somewhere, so it'll actually kind of adjust where the shaft sits. And you can make it so that this pointer, with the natural magnetic field of what it has, is pointing at your 0 or your starting mark. And then once you have that in, that's called a zero calibration, and that's making sure everything is working the way it should. Then what's going to happen is you're going to run a current in through this floating electromagnet. And an electromagnet at this point is just a big coil of wires. It's wire that has just been wrapped and wrapped and wrapped and wrapped and wrapped, and it sits around a shaft like that. So what happens is you're going to run a DC current into this wire. So you got your positive connection here, you got your negative connection, that's going to run out to whatever it is you're hooking it up to. And as we flow current through this wire, one of the properties that this wire exhibits is it starts to generate this magnetic field. Well, this magnetic field, as it gets going through these, is then going to build up, and it's either going to fight or aid into the natural magnetic field that this magnet is producing. So as this magnetic field is getting pushed or pulled on, that is then going to allow this spindle, which is the electromagnet on, to rotate, which then in turn moves the wiper arm one direction or the other. So the more current you have that flows through this coil, the bigger the magnetic field gets, and the more it pushes against the natural magnetic of the magnetic core. So as we go through and moving with this, as we get enough current, this needle is going to move, and wherever it stops, it's been calibrated and set up that now this is where that's reading. So now that's going to read a specific current if the needle was pointed to there. Same with this guy, only it's just going to be in amps instead of milliamps. Now they make these in all sorts of different kinds, different flavors, different things like that. So we have milliamps, we've got microamps. We have some that we use quite often that are like 10 or 10 to 20 or 30 or sometimes even 50 milliamps. I have a couple that are 100 milliamp. So you can really get whatever kind you want to make them use, and they will just measure the value that they're indicated. Now, obviously, if you start measuring too much, that needle is going to go past over here. And inside, it's kind of hard to see, but a lot of times they have a little post that sits right here to keep that needle from going too far. But what happens is physically we've stopped that needle, but if we keep putting more and more current through this, that magnetic field builds and builds and builds. And eventually this thing's going to try to rotate, and it's going to try to put the needle over here. But if there's a pin right here that stops it from spinning, eventually that needle or that arm, instead of looking like this, is going to start doing this. We're going to start bending things, and we're going to start changing how this works. Sometimes we can put too much current through that coil. We can actually burn the coil up, and so then it doesn't work anymore. So we do have to be fairly careful with these, but they are fairly resilient. The needles will, they're designed to kind of go in there up to a certain point. Some of them, even when they hit that little post that lives right in there, they actually create a short, and it actually shorts the signal coming in, so that way too much current can't go through the spindle. But again, it just depends on what type you buy and how much you want to pay for it and things like that. And so the idea behind this analog meter is it is a way to measure voltages without having to have an external power source. It gets powered from the current, essentially, that is running through it. So we're not necessarily using the power, we're just using that magnetic field it creates as it flows through the wire to generate the movement. Which makes this really nice because now we can have this meter and we don't have to worry about replacing batteries, we don't have to worry about making sure we have a power supply to it, and it's something that will pretty much always work. We have a lot of analog meters that we use in the lab, and sometimes those analog meters can be fairly accurate. Sometimes they're more accurate than our digital ones, depending on our range or our scale or things like that, and as long as you're measuring and moving them right. One of the other things that you're going to notice, this one doesn't have it, but there are times when we have scales, and underneath you'll actually see this little metal reflective part. So we'll have it there, and then we'll have our scale that goes from 0 to 10 milliamps or whatever, and then it's got the different markings going through, and then you've got your needle that's pointing up like this. Well, what happens is because right underneath that line we have the reflective surface. Depending on how you look at it, you can actually create a phenomenon called parallax. So as you're looking at something, if you're looking at it from over here, so you're looking from this direction, it's actually going to appear like it's sitting a little farther this direction. If you look at it from over here, it can look like it's actually closer to this side. So what you want to do is you want to make sure you look directly above it as you're looking down onto the analog meter. That way you can see what's going on directly and know right where that needle is pointing. And that reflection, that little mirror gets in there, so if you're looking at it wrong, everything should line up. If you're looking at it at a bad angle, on the reflection, which I'll draw here in purple, will actually be sitting over here. So then you have to kind of adjust your viewpoint so that you have this reflection and the needle lines up, and then you can accurately measure what that is. Now, once we have these in place, we can use these for a variety of different measurements. Like I said, a lot of equipment has these built into them because they don't require any external power. They get their power from the magnetic field, like I said. Other times you're going to have these. You may not have the type that you're after. So sometimes we have to be able to use these in such a way to give us the options that we want. Now, all analog meters are going to be measuring current. That's just how they're controlled. They're controlled by the current. The current creates the magnetic field. The size of the magnetic field determines how far displaced that pointer gets. So every single analog meter is registering and using current. Now, there are times where we're not going to use those types of things, but we're going to have other options when it comes to analog meters. We're going to be able to measure voltage, we're going to be able to measure resistance, things like that. And so, for example, we even have things that look like this. I'll bring it over here. Let's drop this in. So there will be times where we have devices that look like this, and we have analog meters. So on this meter, it has one scale, but it's measuring ohms. It's measuring DC current, measuring AC current. Depending on where we put it, we can actually get it to measure voltage. So with the one meter that is just measuring resistance, we can then use it to measure all sorts of different things instead of just current. Now, like I said, keep in mind, it is current that is making this work. But we are going to say this much current is going to be equivalent to this much voltage, or this much current is going to be the equivalent of this much resistance. So anything that we do with an analog meter can be described and can be listed on there, but again, it's just using how much current flows through the circuit. In the next video, we're going to talk about applications of using these current meters and to solve for different problems, different applications again, how we can use them to get these different functions to measure specifically voltage is what we're going to be after in the next one.